lesson, I'm going to begin talking about units of measurement. You guys are going to review that, and then we're going to work on writing in scientific notation and standard notation. So for units of measurement, as you can see here, they're measurements of length, volume, mass, temperature, and time. Those are what we're going to be working with primarily, although there are going to be other measurements that we work with. Now there are metric units and SI units. Now these are standard units that are used. That doesn't mean that that limits us to what units we can use. However, these are what are standard. For length, the metric unit is meters, and it's meters as well for SI units. For volume, it's liters for metric, while it's cubic meters for SI. For mass, it's grams for metric versus kilograms for SI. For temperature, it's degrees Celsius versus Kelvin for SI. And then finally, for time, it's seconds for both of them. So those are the units that we're going to be using extensively. Once you guys are done with your practice, we'll then talk about standard notation and scientific notation. So for scientific notation, the purpose of scientific notation is to take very large numbers or very small numbers and make them more manageable, to get rid of all of those zeros that you would need for a very large or a very small number, and make it into a number that is between 1 and 10. Now that number which we create, that is called your coefficient, and you're going to multiply that by a certain power of 10. So let's look at how exactly you do that with an example. Here I have 4,300. Notice there's a decimal place after the 4,300, and that's to take care of significant figures, which is a concept that we'll cover very shortly. That just means that I'm going to include the zeros in my answer. So to write this number in scientific notation, remember the number has to be between 1 and 10. So it has to have only the ones place, no tens place. So how many places must you move this decimal? Well, I have to move it over 1, 2, 3 times to make it 4.300. So that's 3 places. Now the coefficient will be 4.300. That's a number that's between 1 and 10. It has to be raised to a power of 3. And therefore the value in scientific notation will be 4.300 times 10 to the third. Now, the reason why it's a positive 3 and not a negative 3 is because I took a large number, 4,000, and made it into a smaller number. So to make up for that fact, I've got to multiply it by 1,000, which is 10 to the third. 4,300 and 4.300 times 10 to the third, they are the same number, just in different notations. Standard notation is the 4,300, while 4.300 times 10 to the third is in scientific notation. Now, in order to convert from scientific notation back to standard notation, since a positive exponent makes the number larger, we need to move the decimal to the right when we're putting it into standard notation. In contrast, if you have a negative exponent, that makes the numbers smaller, and therefore we're going to move the decimal to the left. So if you look at this example here, I have 7 times 10 to the second. Since that exponent is positive, that means I'm going to move the decimal 2 places to the right. And since the decimal is behind the 7, that makes it 700, because I moved that decimal over 2 places and then filled in zeros for those spots. Now, if instead if it were 7 times 10 to the negative second, I would move the decimal place to the left. And since it would be 2 places to the left, it would be 0.07. Okay? And so that's how you convert from scientific notation to standard notation, and standard notation back to scientific notation.